Hi guys, here is a question. Guys, let's attempt it. I read it first. Two resistors of resistance R1 and R2 have effective resistance of 9 ohms when connected in series and 2 ohms when connected in parallel. Show that R subscript 1 squared minus 9R1 plus 18 is equals to 0. Roman 2. Hence, determine the values of R1 and R2. So guys, we do this question. And let me write the basic, what is required. We are required that effective resistant, or maybe I can do it while it is. Let me show you guys what I will do. So guys, I will write like that. So that now when they are in series, you have something like this, guys. Then we have R1, R2, like that. So guys, when we come now to finding, for example, we can use this equation, guys, that is V is equals to IR. And so guys, the PD across R1 and R2 is now going to be I, which is going to be constant throughout R1 plus I R2. This one now, guys, we shall have, it will be equal to I, which is the same, now multiplied by the effective resistors, which is now going to be 9, like that. So guys, we can now cancel the I there because they are the same throughout. So R1 plus R2 will now be equal to 9. Guys, let's go to the next step of parallel circuit. We shall have a parallel circuit will look something like this. Guys, that is a parallel circuit. We have R1 here, we have R2 here. So guys, working with that one, we can now talk of the current. The current across R1 is given by V all over R1. This is equals now to I1, like that. The current across R2 is V all over R2. Remember guys that the V will be the same for circuit which is parallel. So this is I2, like that. And so I1 plus I2, guys, this gives us the total current. And so writing it in form of V and R, we shall have V over R1 plus V, which is the same. We said V is the same, R2. This now, guys, gives us the total current, which is supposed to be V all over the effective resistance. And the effective resistance, guys, is supposed to be 2 for parallel. In other words, when we talk of effective resistance, if it were to be 1 resistance, how much would it be? It's now supposed to be 2. And so guys, we can now cancel the V. Can cancel that, and cancel that. So guys, we are left with 1 over R1 plus 1 over R2. This gives us 1 over 2, like that. And so guys, we can now, from there we can do like this. Find the LCM for that. This is we can draw a line there. LCM for that is R1, R2, like that. You divide that by 1. Here you shall get R2 plus R1. This now gives us a half. So guys, we are now supposed to show that this is equals to 0. So guys, what we are going to do, because we have another equation here, guys, we have this equation. We are going to replace that equation in this equation, whereby we have R2 plus R1. And so therefore this is now going to be 9. R2 plus R1 is 9 all over R1 R2 equals to a half, like that. And remember guys that since R1 plus R2 is equals to 9, therefore we can say that R2 is equals to 9 minus R1, like that. So let's remember that, guys. And so guys, from there we continue, we cross multiply. When you cross multiply, you get 18. 18 is equal to R1 multiplied by R2. Guys, we can now replace for R2. So when we replace for R2, we will get 18 there equals to R1. Then you place R2, which is 9, minus R1. And then you can now expand this. This is 9 R1 minus R1 squared. So that can form a quadratic equation. So we can bring R1 squared to this side. That is R1 squared. We also bring this other side, it becomes negative 9 R1, then plus 18. This one gives us 0. And so guys, we now come to our solution we were looking for. So this is the solution we were looking for, guys. And so guys, this is correct. We now go ahead and determine the value of R1 and R2. And so we find two numbers. If you multiply, guys, you get 18. If you add, you get negative 9. And that is negative 3, negative 6. And so we write here R1 squared minus 6R1 minus 3R1 plus 18 equals to 0. And so guys, we can now put the bracket, that is R1 squared minus 6R1 minus, we put another bracket here, 3R1. This one we are now going to put negative 18 because of the bracket. This is now equals to 0, like that. Guys, we can factor out the R1 here. R1 like that. So we are left with R1 minus, this is going now to be 6, like that, minus, we can factor out 3. So guys, we are left with R1 minus 6, like that. So guys, this one gives us 0. And so therefore, guys, R1 minus 3, can factor out R1 minus 3, we are left with R1 minus 6, like that. This is equals to 0. And so therefore, R1 is equals to 3, or R1 is equals to 6. Having found that, guys, we can now go back to our equation of where we say R1 plus R2 is equals to 9. So guys, using this first value of R1, we shall have 3 plus R2 equals to 9. And so therefore, R2 is equals to 6 ohms. We come to this other one, we say this is now going to be 6 plus R2, that is R1 we are saying is 6, plus R2 goes to 9. And so therefore, we are going to have 3, we are going to have R2 is equals to 3 ohms. So guys, these are our solution, that and that. So bye bye.